My dear students, we now continue with chapter 3 of science part 1, that is chemical reactions and equations. Now last week you learnt in this lesson what is a chemical reaction, what is a chemical equation, what are the various steps involved in writing a chemical equation, and what information is conveyed or shown by a chemical equation. Now today we learn about the various ways of classifying chemical equations. So let's proceed with the first type of classification. Now boys, you can see on your screen there are some reactions given there, some chemical reactions. Now before I ask you the question, I just want to tell you something. Is if you can see on your right hand side, boys, if you can see this on your right hand side, there is something written in brackets, like for example this word heat is written in bracket. Now these actually this is the condition required for this first reaction, carbon plus oxygen giving carbon dioxide. But because of space constraint, because there's a space problem, I have written it on the right hand side. Actually this word heat should be written on the arrow, should have been written on the arrow. I should have written it here rather, saying it is heat here, no, like this. But because all the equations with these things will not fit on the screen, so in all the reactions on this slide and in the coming slides, all the conditions required for carrying out the chemical reaction is I have shown it on the right hand side in brackets in red color. Okay, just keep this in mind. Just want to tell you. So let me rub this off. So let's begin. Now, as you can see, boys, I want you to observe and tell me what is common to all these reactions. Now, don't look at the symbols and the formulae. Just look at the reactants and the products, and you will find something very common, very simple. I don't want you to think very hi-fi. Just think like basic thing. So, what do you feel is common to all these reactions? Have a look. Yes. So what is this? Is a deductive method. I want you to tell me what is it, and we'll find out the answer then. Okay. So we'll deduce. This is a deductive method which I'm using for teaching this. So it becomes interesting. Now I'll tell you the answer. What is it? So check whether you also are thinking in the same direction. As you can see in all these reactions, if you can see, there is only one product. See, can you see CO2, NH3, NH4Cl, calcium hydroxide CaOH2, and CaHCO3, that is calcium bicarbonate. In all this reaction, if you see, there is only one product. What about the reactants? There are many. In the first question, in the first reaction, there is carbon and oxygen. Second also carbon, nitrogen and hydrogen. Third reaction, ammonia and HCl. Fourth reaction, calcium oxide and water. Fifth reaction, calcium hydroxide CaOH2, H2O and CO2. So reactants are two or more than two. Like in the last reaction, there are three reactants. But what about products? There is only one product. Now such reactions where you can see only one product, such kind of reactions are called as combination reactions. They are called as combination reactions. I'll just rub this off. Okay. Now, what is a combination reaction? A chemical reaction in which two or more reactants combine to form a single product is called a combination reaction. So whenever you see a single product, so why this called combination reaction? Because two or more reactants, with this 2, 3, 4, 5, any number of reactants, they all join to give you one single product. That's why it's called a combination reaction. I hope it is clear. So whenever you see one product, you have to understand that it's a combination reaction. Simple. Let's continue. Now again the same question I'm asking you. Find out what is common to the reactions given below. Now it is very easy because last time I already you know the answer, so more or less now it will strike you more easily what is common to all these reactions. Think in the same direction. Now it is very easy. I suppose all of you must have got the answer. So what is it? In all these reactions, what is common? Yeah, yes. You can see in all this reaction there is only one reactant. Can you see? C12H22O, that is what? Sugar. H2O2, that is hydrogen peroxide. NaHCO3, that is baking soda, you learned last year. NaCl, apna common salt, table salt, what you put in the food for cooking food. H2O is famous, nobody, everybody knows H2O, water. AgCl, silver chloride, and AgBr, that is silver bromide. Now what you can see in all these reactions, see, there are in this there's only one reactant. But what about products? There are two products, or there's something. There are three products. Can you see the third reaction? There are three products: NaOH, H2O, and CO2. So products can be two or many, but reactant will always be one. And for carrying out all these reactions, you can see I have given the conditions on the right hand side in the brackets. Now I given it there, as I told you. Why? Because there is actually this all this what I've written brackets should have been written on the arrow, as I told you last time in my last slide. But here, because of the space problem, I have written it the right hand side. Okay. Now in the exam, be careful. These conditions for the reaction to take place, you have to write it on the arrow. This heat should be written on the arrow. The electric current also should be written on the arrow. So what are these reactions where you see one reactant, and each reactant, as you can see, is breaking down into two or more than two products. Like in the third reaction, NaHCO3, you got three products. So sometimes you get 2, 3, 4, 5, any number of products, but reactant is only one. Now such a, I'll just rub it off. Sorry. Okay. So all this, so these kind of reactions, we call them as decomposition reaction. Why decomposition reaction? Because each reactant is decomposing or breaking down into two or more products. So that's how we define a chemical reaction in which two or more products are formed from a single reactant is called a decomposition reaction. You can write in your own way. You can also say a chemical reaction in which a single reactant breaks down or is splits into two or more products is called a decomposition reaction. So easy. Now things don't break down on their own. Things don't decompose or break down on their own. Okay. For things to break down, you have to supply energy. You have to supply energy. Now for the first three reactions, I have written on the right hand side, the word is what do you need to do bring about these three reactions on the, can you see here? You need heat. You need to supply heat. The first equation, actually first equation, what you can, first reaction which you see is C12H22O11, that is sugar. Sugar on heating breaks into C for carbon and H2O, that is water. H2O2, the second reaction, H2O2 is hydrogen peroxide, on heating breaks into water, H2O, and oxygen. Same way, baking soda or sodium bicarbonate, the third reaction, on heating breaks down into sodium hydroxide, water, and carbon dioxide. So what about the second one? the fourth and the fifth reaction, to break down NaCl and H2O, what do you have to pass through it? You have to pass electric current through it. You have to pass what through it? Electric current. So when you pass electric current through sodium chloride, molten or liquid melted sodium chloride, it you get sodium at the cathode and chlorine gas at the anode. And water, when you pass electric current through water, acidified water, through acidified water, you will get H2 and O2, that is hydrogen at the, where hydrogen you will get at the anode, and sorry, hydrogen will get at the cathode and oxygen will get at the anode. And for the last two reactions, what do you need to break down silver chloride AgCl and silver bromide AgBr? You need sunlight. So when silver chloride is exposed to sunlight, it breaks down or decomposes into silver and chlorine gas. And similarly, AgBr, that is silver bromide, when it is exposed to sunlight, it breaks into silver and bromine gas is evolved. Okay. Now, boys, AgBr is silver bromide, which used to be used in photographic films in the earlier day when there were no digital cameras. When they used to use those Kodak cameras, photographic cameras, we used to use a camera roll inside it. So whenever it was exposed to light, the photographs is to get spoiled. Why? Because it contained silver bromide. So I hope this particular reactions are what is that this particular type of reaction is clear to you. Decomposition reaction, how do you identify decomposition reaction? You will, whenever you see a single reactant, you have to understand it's a decomposition reaction.